Welcome to The Explainer. Today, we're tackling a question that I'm sure you've screamed at your phone at least once. Why can't my AI assistant handle a simple, real-world request? We're going to dive into this massive gap between what we think these AIs can do and what they actually really struggle with.
You have absolutely been there. You ask your smart assistant to do something that involves just a little bit of real-world messiness, like plans changing at the last minute, and it just completely fumbles. And you're left there wondering, why is this so hard for something that's supposed to be a super intelligence? I mean, take a request like this one, book a cab, and hey, if my friend changes the meeting spot, just update the destination. It sounds so simple for a person, right? But this kind of on-the-fly adaptation can totally trip up even the most powerful AI assistants out there. They really struggle with it. But a brand new challenge, a whole new kind of test, is being built to change all of that. So what's the real problem here? Well, researchers figured out that the tests we've been using for AI were just too clean, way too predictable. They weren't testing for the chaos of real life. So they decided they had to build a much tougher and way more realistic digital obstacle course.
Yeah, and this is the key difference. See, the old tests, they were kind of like a quiet multiple-choice exam. Everything was predictable. This new benchmark, though, it's called Gaia2, and it's designed to be a chaotic, messy free-for-all that perfectly mimics a real smartphone environment, with notifications popping up and things happening all the time.
And this really lays out the new rules of the game. Gaia2 isn't just testing one simple thing. It's evaluating 7 core capabilities all at once. It's looking at everything from basic stuff like just executing a command to much more complex skills like adapting when conditions suddenly change or handling requests that are vague, and even dealing with digital noise that's designed to distract the AI. It is a comprehensive workout, for sure. Okay, so the stage was set. This incredibly difficult new test was ready to go, and the world's most advanced AI models, yeah, the ones powering the tools that many of us use every single day, they were all invited to compete.
So the big question is, how did these AI titans actually do on this tough, realistic new challenge? I mean, did they live up to all the hype, or did the real world prove to be just a little too much for them?
Well, the results were pretty shocking, actually. The best performing model, a highly advanced version of OpenAI's GPT, it passed the test less than half the time. It scored just 42%.
And as you can see from this chart, that wasn't just a fluke. No model even came close to mastering this test. The results really revealed this massive sim-to-real gap. That's the huge difference between how AIs perform in a clean, perfect lab setting versus how they do in the messy, unpredictable real world. But here's where the story gets even more interesting. When you look beyond just those final scores, the test uncovered some really fascinating, kind of hidden trade-offs that these AI models are constantly making behind the scenes. It turns out you just can't have it all. As the researchers themselves put it, there's this fundamental trade-off. An AI can be smart, or it can be fast, or it can be affordable. But right now, you have to pick. You can't have all three. Now check this out. This chart gets right to the heart of that cost trade-off. What we're looking at is overall performance going up against the actual cost per task going across. And you can see this super clear trend. The models on the right, the ones with the highest scores, are also by far the most expensive to run. Basically, being smart costs money. But here's the biggest surprise of all. The test revealed something the researchers called inverse scaling. And what this chart shows is that the smartest models, the ones that are best at complex, deep reasoning, were often the slowest when it came to time-sensitive tasks. Their deep, careful thinking took so long that they just completely missed the deadlines. It's almost like they were overthinking the problem. This total failure on time-sensitive tasks, it raises a really crucial question, one that the researchers also wanted to explore. What if AIs didn't have to work alone? Could a team of AIs working together actually perform better than one single giant AI trying to do everything by itself? So the test explored this concept they call agent to agent, and the idea is actually pretty simple. You have a main AI that acts like a project manager. It gets a complex problem, it breaks it down into smaller, manageable pieces, and then it delegates those little pieces to specialized helper AIs. So, did this whole teamwork thing actually work? Well, the answer is a definite yes, but in a very specific and kind of surprising way. What you can see is that teamwork dramatically boosted the scores for the weaker models, really helping them punch way above their weight. But for the already strong models, the benefit was pretty minimal. They were already so capable on their own that adding teammates just didn't give them much of a lift. Okay, so let's put this all together. What does this all mean? What do these surprising results, the failures, the trade-offs, the teamwork, what do they tell us about the future of AI assistants? Well, the biggest takeaway is crystal clear. This dream of building one single, all-powerful, super genius AI that can solve every problem, that might be the wrong goal entirely. Instead, the real path forward seems to be all about building flexible and efficient systems. And that means using ideas like adaptive computing, knowing when to use a fast, cheap model versus a slow, powerful one. And it means building these collaborative teams of specialized AI agents that can work together, with each one playing to its own unique strengths. And all of this leaves us with a final question to think about. Is your next AI assistant going to be a single, isolated genius? Or will it be a well-coordinated team? The answer to that question could very well define the next decade of artificial intelligence.